The last example we saw was an example of multiple reflection. The multiple reflection means that there are different reflecting objects present, more than one. Such that the image of first reflection becomes the object of the next. Image of one becomes the object of next. The total magnification produced is the product of multiplication of total product of magnification of individual M1 reflections. Okay, it goes on like this. Now let's take an example. It says, let's assume that there is a concave mirror M1 and a convex mirror M2. These are placed coaxially facing each other. So it says that they face each other coaxially. So the construction is like this. This is my M1, this is my M2. Okay. Now consider, it says that there is a small object. There is a small object placed here. Okay. Now the question is that the first reflection is on the concave mirror M1 and then the second reflection is on the convex mirror. Now it says for different positions of the intermediate image, see the intermediate image can be formed here, here or here depending on the position of the object. What is the intermediate image? The intermediate image is the image formed by the concave mirror. So my intermediate image can be formed here, here or here depending upon the position of the object. So it says that for three different positions of the intermediate image, what conclusion can be drawn regarding the nature of the final image? So depending on the, it says that depending on the position of the intermediate image, find the position of the final image, or find the nature of the final image rather. Okay, so let's do that. You can try this question on your own, but I would suggest that see the solution so that the concept of sign convention becomes more clearer. So let's take first case as when the intermediate image lies here, second case when the intermediate image lies here, and the third case when the intermediate image lies here. Okay. So let's take one by one. Case 1. The intermediate image is formed here, away from the object. That means what? What does that mean? It means that my object is placed between infinity and center of curvature. Because when the object is placed away from center of curvature, the image is formed away from the object. So my object is surely placed here. And what will be the nature of the intermediate image? If I call the initial object as U1 and this one is V1, this one is V1 and the final image is V2. So what is U1? What is the focal length of this one as F1 and this one as F2 convex mirror? What is U1, F1 and V1? What is U1? U1, what is the real space here? Real space is this part. So my U1 is positive. Okay. What is my V1? V1 is also positive, and what is F1? F1 is also positive. How did I figure out that U1 is positive? I moved from the object to the mirror. This direction of movement is the same as the direction of the incident ray, so U1 is positive. And this. Now, it's a real image. So, since it's a real image, there's an inversion taking place. Okay. Now, for this mirror, my object is this one, V1. So I call it as U2. And my final image, let's assume it as V2. So my final image can be formed here or here. Okay. So my final image can be formed here and here depending on the distance d. Now if my final image is formed here, so for this mirror, this is my object, this is my image. So U2 is my object. What is U2? Negative or positive? I move from the object to the mirror. My direction of movement is this, but the rays strike in this direction. So U2 is negative. What is F2? It is negative. And what is V2? V2 is, if the image is formed here, V2 is negative. If the image is formed here, V2 is positive. I exactly don't know where the image is formed because I don't know this distance. Okay. So what can I say? If V2 is negative, what is the case? If V2 is negative, will there be an inversion? And if V2 is positive, in which case there will be an inversion? The question is up to you. You tell me the answer. Well, when V2 is positive, there is no inversion. And where V2 is negative, there is inversion. Now the question is why? You see that in case of a convex mirror, when the object is here and the image is formed on the other side, there is always no inversion. So that means when the object and the image are on the opposite sides, there is no inversion. When the object and the image are in the same side, there is inversion. So here you see, in this case, the object and the image are on the same side. So there is inversion, which is this case. The object and the image are in the same side. When they are on the opposite sides, as in here, there is no inversion. Okay. Now the second case. The second case is when the image is formed here. So image is formed here. So image is formed here. Let's do it orally. So for this one, for the first mirror, object U1 is positive, V is positive, F is positive. For this convex mirror, and there's an inversion here. For this one, object is here, I move in this direction to the mirror, incident ray also in this direction. U2 is positive, V will be formed here, it's negative, F is negative, because real space is here, virtual space is here for this mirror. And for this reflection, there is no inversion. So finally, there is an inversion occurring. Inversion plus non-inversion. So there is an inversion occurring. Now let's take the third case. Third case, when the intermediate image is formed here. That means what? That this is my real space for this one. So the image is formed in the virtual space. So it's negative. Focal length is positive. What is U1? Same direction as the incident ray. So it's positive. Now let's take, so, and there's no inversion taking place, because you know that when this virtual image formed on the concave mirror, there is no inversion. What is for this one? This is the object. F2 is negative because focal length is this side, real space is here. V2, image is formed here, so this is again negative. What is U2? Same direction as the incident ray, so this is positive. No inversion. So finally there is no inversion. So you see, as a rule of thumb, what you should remember is, when U and V are of opposite sign, there is no inversion taking place, as here, as in this case. But so U and V opposite sign, no inversion. This is a general fact. U and V same sign, inversion takes place.